Hi guys, I just wanted to create a little video to help you with mean value theorem because a lot of people were asking about that when you did your reflections. So mean value theorem, as you can see here, is very important that you just know the conditions. That condition number one is all the function needs to be is continuous on the closed interval and differentiable on the open interval. And if those two conditions apply, then this is what can be guaranteed, that there is some c in between those x values such that the slope of that original function is equal to the derivative, okay? That the slope of the original function is equal to the derivative instantaneous at some point. Okay, so let's get into this first one just to go over quickly. So some people said they had trouble with finding that value when they give you that. I know you've seen this question, so you can pause it and read it again if you want, but I'm gonna get into this. So is there a value A on this interval for which mean value theorem can apply? So when I look at this interval is saying from -4 to 6, and if I think about that, and they're talking about f, I believe it's called f, right? Theorem applies. Yeah, they're talking about f. All right, so if I think about it, is f continuous on this interval when you first start thinking about it? Well, I go from here. Do I lift up my pen whatsoever? Whatsoever, I do not. So yes, it is continuous. Is f differentiable on this open parentheses interval? Sorry. So is f differentiable? Well, the fast way to know that is to go back here and see if there's any corners or cusps. That looks like a corner cusp mix. I have no idea, but definitely not differentiable at x equals 0. Okay. You say it's not different because of the corner cusp. Okay, you can say because of a corner cusp. That's totally fine. But I know that they are, oops, that's backwards. I know that they're getting pickier with that. And for not differentiable, that means the limit as x approaches 0 in this case, because that's the number of question, of f prime from the left does not equal the limit as x approaches 0 from the right of f prime. Just think about what that means. That means the what of f, the slope of f, from the left does not equal the slope, okay? The slope, not the actual value of f from the right, okay? So that's why, since we're saying slope, that's why we need to put primes in here of that, okay? So you're saying the limit of the slope being approached from the left does not equal the limit of the slope being approached from the right. This slope is some constant number. I don't know, negative, what that is. What's it going up? It's going up like 3/4 or something like that. Whatever that slope is, this slope's changing and getting steeper, and they're just not approaching the same slope, okay? So that's one of the things. Now, you didn't have to analyze all this. None of this was required for this question. It was just an observation I was making, okay? I just want you to know that. So now, to answer the question, they want to know, is there a value A? So, obviously, is there a value A? Let me finish this. For which the mean value theorem applied, so that A is one of the endpoints. So, okay, we can't use -4 to 6. So they're saying that's obvious because it's not differentiable. So they want to know, what A value can you use? Well, if it's going all the way to 6, I certainly can't use any of these A values. That's just not going to happen because it hits a differentiable. So my A value has to be somewhere in here. So which A value do I pick? Do I pick 1, 2, 3? I mean, I guess I could pick 0, but because it is continuous from 0 to 6. So this is how I process my thought here. I'm just going to erase all this because I don't really need this right now and go back to get into the question. So my process here is I wanted to say, okay, what can it be? I mean, if I picked from 0 to 6 and was like, okay, yeah, maybe it's 0 to 6. I mean, it's continuous on that interval. It's differentiable. I don't lift my pen. It's differentiable on the open interval of 0 to 6. Like, I guess I could do that. But let me ask you, that's fine. That can be done. But they want very specifically that you find the particular a value, whether it be 0, 1, 2, 2.5, I don't know, any of these numbers all the way up to 6. And that number has to create this. It has to create this. Okay, so what does that mean? That means that the slope, so that means that f of 6 minus f of a over 6 minus a has to equal 1 over 3. That is how you're going to find the a value. You have to figure out which is it, which a value it is. It's going to give me that slope. You can look at the graph and go, well, what's going to give me that slope? You can be like, well, I'm just going to erase here and have you guys focus here, and you can kind of get some ideas on what that can be. I mean, if I pick this value, that slope is definitely not looking like anything positive. I could pick maybe, okay, I can be like, okay, it's not that one. So let's go back. Maybe it's at 1, like around here. I don't know. At 1, look at these y values. If that was 1, like, I don't know if that's 1, 1, but whatever it is, it does look like a slope of 0. That's probably not it. So we're looking somewhere more along these lines, okay? So you know it's got to be a slope of up 1 over 3, okay? So it's not very steep. All right, well, why don't we just solve this? So f of 6, well, that's easy. That's 1 minus, I don't know what f of a is going to be, right? Over 6 minus a has to equal 1 over 3. I'm gonna cross multiply this. I don't know if this is the easiest. Honestly, I just would pick values. I think that's the easiest way to do it. Like, I would look at this coordinate. Like, I know, because I can't be sure of any of these coordinates, but the only one I can be sure of is they told me that x is tangent at 3. Like, I know that coordinate. I know that coordinate is 3, 0. Can we just check that one out? Let me see. If I know that that's 3, 0, then if I do f of 6 minus, that's this, the x value, minus f of 3 over 6 minus 3, right? Those are my x values. So f of 6 is 1 minus f of 3 is 0 over 6 minus 3 is 2. Is 3. So then this is going to be positive 1/3. Oh, that's it. That's the one we wanted. That's what they want you to do. They want you to go through all this trouble figuring out, see if you can do this algebraically, come to the conclusion that's not going to work. Let's go back. Let's try this. I have this value. Oh, it works. Okay? This is the process, the figuring out, the not giving up, like the not sitting there and going, hey, I saw this exact question once before in my AP calculus class. I can do it. It's not like that. It's like they really want to challenge you. Okay? So I'm going to erase this and say I don't really need this part. Or you can put a little slash through it. It doesn't really matter. None of it, they wouldn't really take it against you, I don't think, anyway. So now all you have to say is, so what is that? So make sure you answer the question. So is there a value a? You say yes. A is equal to 3, right? And then you can say because f of 6 minus f of 3 over 6 minus 3 is equal to 1/3. And the conditions, of course, you have to say the conditions. You have to say f is continuous on the interval of 3 to 6, and f is differentiable on the interval of parentheses 3 to 6. And if you ask whether the parentheses and the brackets matter, smack yourself in the back of the head. Of course it matters. So yes. So get that right. And pretty much we've given everything. Conditions, the formula, we showed that we knew slope. We're good. Moving on. That's one of the questions people ask. This is how you handle it. You just kind of look at it, figure it out, and you can. Another one that you guys asked about was this one. Okay, this one was good. I started to do this, but I was too rushed in the WebEx, so this is going to be good. So let's see. So I know you know it already. So if you need to pause, read it again before I get started. Find the average rate of change. of G prime. They ask you many questions in here. So you do this and you just get it done with and make sure you get your credit. They do this a lot where they ask many questions into one. So make sure you answer everything. So that's G prime of 7 minus G prime of negative 3 over 7 minus negative 3. So that's a 4 under here. So G prime of 7. This is a G prime graph, so you just read that. So that's 1 minus and negative 3. So this is G prime of negative 3 is negative 4. So that's negative 4. So then this is equal to 5 over 4, right? G prime of negative 3. Yeah. Okay. So hopefully, I feel like I plugged that in wrong. So it's 1 minus negative 4. Yeah. Over, yeah, that's fine. Okay. Anyway, that's what you had to do. Fine. Now, does the mean value theorem apply on here? Well, let's find out. Well, first of all, they're talking about does the mean value theorem apply in here and guarantee that there's a C such that G double prime is equal to this average. So in order for G double prime, because mean value theorem is saying, like, let's say you have a function, then mean value theorem says that if you have a function, you take the slope of it, right? So this is the slope, when talking about the mean value theorem, this is the slope of G prime. Okay, so in order for you to be able to apply that, you have to say that G prime is continuous on negative 3 to 7, which G prime, this is a G prime graph from negative 3 to 7. I'm going to take my pen, and do I lift, do I lift, do I lift, ever, ever, ever? I do not lift, so the answer is yes. G prime is differentiable on the parentheses interval from negative 3 to 7. That's the open interval. And I'm going to look at that. And on this open interval, I'm going to be like looking at that to look for differentiability. And that means I'm looking for corners now. And I'm like, corner, nope, corner, nope, corner. No, it is not differentiable on 3 occasions. So no, not differentiable at, negative 1 at x equals negative 1, 1, and 4. And you can say because corners, no one's going to be upset with you if you say that. If you have time and you want to be all, crazy about it, you can say because the limit as x approaches, we'll just call it x1 for G prime double prime. So the slope of that does not exist at those x1 values. Okay? Yeah, if you want to, honestly, this is just one way to say it, and that's using the limit thing. Remember, you're taking the limit of the slope, not limit of G prime. It's limit of G double prime because the slope of G prime. All right, that's